We're interested in the Great Circle distance from Chicago to Auckland, New Zealand. Now, the shortest distance would be a straight line that would go through the middle of the Earth, but obviously that is not a realistic path. The Great Circle distance is on the surface of the Earth. So, what would that distance be? What information do we need to get there? Well, first off, the Earth is not exactly a sphere, but it's pretty close. The radius at the poles is a little bit less than the radius at the equator. So the Earth is actually an oblate spheroid, so it's flattened out as the Earth rotates. The North and South Pole come a little bit closer to each other. But for the sake of our discussion, we're going to assume that it is a sphere. It is pretty close. Now, to answer this question, we need to know some things. We need to know the radius of the Earth. And that is about 3959, 3,959 miles. We also will need the latitude and longitude for both Chicago and for Auckland. So let's get that information. So here's the data that we have, and we want to convert these things into spherical coordinates to make some sense for us. Now, certainly rho for each of these, the spherical radius will be the same. Will be 3959. Now, how does latitude work? Remember, latitude for the North Pole, latitude is 90 degrees here and 0 degrees at the equator. So in terms of figuring out what phi is going to be, how are we going to make that decision? Well, phi for 41.84 degrees north, we're in the northern hemisphere. So if that's the case, we are measuring 41.84 from the equator. That's not phi, this is phi. So to get phi, it's going to be 90 minus 41.84 degrees, which is going to give us a phi of 48.16 degrees. And then as we jump over to Auckland, what do we have to understand? Auckland is in the southern hemisphere, and that's 36.84 degrees south. So how do we make sense of that? 0 degrees is at the equator, and we need to go another 36.84 degrees here. So our phi is going to be this. So our phi in the case of Auckland is going to be 90 plus the 36.84 degrees. So our phi is going to be 126.84 degrees. Well, next up, how do we make sense of theta? So theta is equivalent to longitude. We consider west as negative, and we can consider east as positive. If that's the case, 87.68 degrees west can be thought of as negative 87.68 degrees in the case of Chicago. And in the case of Auckland, east would be considered positive. Theta would be 174.74 degrees east. So that's how we can measure phi and theta in terms of degrees. We can easily convert those to radians to make it work with our model. But that's what we're starting with. We have rho, phi, and theta for both of these cities, and we're going to use that information to find the Great Circle distance. So there's our data. We see the center of the Earth is here. So this would be OC, and this would be OA, and we want to find the angle gamma between those two vectors, and that will enable me to find the distance between those cities. So what do we have to do to get there? Well, we need to convert these things into rectangular coordinates. So can we do that? Let's quickly remind ourselves of our triangles that we work with. So this is Z, this is rho, this is phi, and this is r. So if we want to find Z, cosine of phi is Z over rho. So rho cosine phi equals Z. Okay. So let's see what that is then in terms of Chicago, in terms of Auckland. In terms of Chicago, rho is 39.59, cosine phi, cosine of 48.16 degrees. That'll be the Z for Chicago. And in the case of Auckland, it'll be 39.59, cosine of 126.84 degrees. Will equal Z. So let's see what those things are. So doing the computation, we have Chicago is at 2640.86 and Auckland is at negative 2373.75 for the Z values. So we have Z, we need to figure out what X and Y are. So let's go ahead and do that computation. So cosine of theta is X over R. So R cosine theta is X. And similarly, sine of theta is Y over R. So R sine theta is Y. And what is R? Again, going back to this triangle, we see what? We see sine of phi, opposite over adjacent. Looking at that triangle, we see sine of phi is R over rho. So rho sine phi is R. So if that's the case, then we get rho sine phi cos theta is X. And rho sine phi sine theta is Y. And we have our values up here. So we can go ahead and we can plug those in. So let's do Chicago first. Rho is what? 39.59. Sine of phi, sine of 48.16. Cosine of theta, cosine of negative 87.68. That's going to equal the X value for Chicago. So let's see what that is. And we get that value, get 119.40 for Chicago. Now doing the X for Auckland, what are we going to get? So recognizing that rho sine phi cos theta is X, rho 39.59, sine phi, sine 126.84, cosine theta, cos 174.74, and we get negative 3155.1 is the X value for Auckland. We've got to do the same thing for the Y values for both Chicago and Auckland. Remember, our rule for the Y values will be what? Rho sine phi sine theta is Y. So let's go ahead and plug those values in. So plugging in the values again, rho sine phi sine theta, plugging in the values for Chicago, we get negative 2947.08 is the Y value for Chicago. Now let's do the same thing for Auckland. Again, there's the rule, rho sine phi sine theta, rho sine phi sine 126.84 sine of theta, sine of 174.74, and we get 290.47 for Auckland. So now we have X, Y, and Z for both Chicago and Auckland. So let's take a look at that. And those are the values in a table. And we have to think about those points as vectors on the sphere. So we have these 2 points. So here's the origin, origin to Chicago, origin to Auckland. And then my goal is going to be to find the angle between them. So we need to keep in mind what those things will be as vectors. So from O to C is that vector. Notice we just have the same X, Y, Z components, same thing as O to A. Now I would like you to check the following, that the magnitude of OC should be how much? From the center of the sphere to Chicago should be the radius of the Earth that we've said was 3959. Similarly, the magnitude of OA should be 3959. Now, how do you check that? What's our strategy to check that? Take OC dot OC and then take its square root and see if that's correct. And indeed, for the Chicago number, I get 3958.999675, so I feel pretty good about that one. And for Auckland, I'm getting its magnitude is 3959.00466. Again, I feel pretty good about that one. But now what do we need? We need the dot product. So what is OC dot OA? So a lot of computation here. 119.4 times negative 3155.1 plus negative 2947.08 times 290.47 plus 2640.86 times negative 2373.75. What does that give me? So I get something about negative 7501499. Very large number. You may have some differing numbers at the end depending on how you round it. And then how do we go ahead and figure out that angle gamma? What's our strategy? What's our rule here? We know that OC dot OA is magnitude of OC, which we know what that is. That's the radius of the Earth, times the magnitude of OA times the cosine of gamma. So what we get here is we get the negative 750.1499 equals 3959 times 3959 times cos gamma. Doing the algebra then, what does cos gamma equal? I get about negative 0.4786, which tells me that that angle is going to be obtuse. Yes, if the cosine is negative, I have an angle between 90 degrees and 180 degrees. So gamma is the inverse cosine of negative 0.4786. And what does that give me? In the world of radians, 2.0699. And then how do we go ahead and finish this problem? We're looking for that great circle distance. So that is a fraction of the circumference. The great circle has the same circumference as the equator or north to south pole. So the great circle distance, which will be the distance on the surface of the Earth, will be the fraction of the great circle times the circumference. So our great circle distance will equal the fraction 2.0699 divided by how many radians do I have altogether for an entire circle? 2 pi for the entire circle times the circumference, which is 2 pi times the radius. So there you go. There you get your radius times the angle measured in radians. So we get 2.0699 times 3959 miles. And then what is my result from that? 2.0699 times 3959 miles gives me about 8195 miles. So that's what we believe our great circle distance as the crow flies, or as the airplane flies, between Chicago and Auckland, pretty close to 8,200 miles. Now let's see how close that is to what we get from some internet resources. So asking Wolfram Alpha, distance from Chicago to Auckland, they are telling me about 8186, pretty close to 8195. We're differing by 9 miles out of around 8,000. I'd say that error is pretty good. And let's check one other place. Chat GPT tells us the distance from Chicago to Auckland is about 8,200 miles. We said about 8,195, so we feel pretty good about our approximation using spherical coordinates and the dot product.